Hello class and welcome to today's lesson 6.3 where we're going to be proving quadrilaterals are parallelograms. So if you remember from yesterday's lesson we learned about parallelograms, all the different properties of them. Today's goal is to determine if quadrilaterals are parallelograms using those properties. So I'm going to go fairly quickly through these first couple slides, right? This is just review about our properties from yesterday. If you want to write those down, you can. I'm going to jump past them here pretty quick. These are our theorems, and now we're going to try to prove a quadrilateral is a parallelogram. So we look at this first example. Is this a parallelogram? Right, notice we have two opposite sides that are congruent, but we need to have either both pairs of opposite sides congruent or that the opposite sides are both congruent and parallel. So in this case, no, right? We don't have enough information here. Okay, now we look at the next one here. Right, if we look here, we go, okay, these angles, right, those tick marks there, or arcs, are telling us that these are congruent to one another. So I'm just going to choose an arbitrary number. In this case, it's going to be 60 degrees. So looking at this information, right, if those two are 60 degrees, the ones across from each other, and then we have this one out here that is also 60 degrees, well, that makes this one 120. And now if we think about a parallelogram, right, opposite angles had to be congruent, and then every consecutive angle had to be supplementary, and that is true in this case. Right, this would also be 120. So is this a parallelogram? Yes, it is. Right, yes, we have enough information to say it is. Look at our third one here. It says, is this a parallelogram, right? If we think back to what I just said about that first one, right? We have that these sides are congruent, right? So that's part of it, but we need at least one other piece. And in this case, we have that they are also parallel to one another. And right, that was one of our properties from yesterday. So is this a parallelogram? Yes, it is. Now looking here, right, again, we look and go, okay, well, opposite sides are congruent, right? Those ones are, and then these ones are as well, right? So we have both pairs of opposite sides congruent. So yes, this is a parallelogram. Going to our next one here, again, same process, except this time we don't have numbers. We just have, hey, all four of them are congruent. We don't need all four of them to be congruent. We just need that opposite ones are. And if we look here, yes, opposite, both pairs of opposite sides are congruent. So yes, this is a parallelogram. So now looking at this one, right, we got to be careful. If you just look at it right away, right, this pair or this set of consecutive angles, they are supplementary, right? That's good to go. But we don't have enough information to say for sure we know that this angle is 60. We don't know what that is. We can't say for sure that this angle is 120. We don't have that information. So in this case, is this a parallelogram? No, right? We don't have enough information. There we go. No, it is not. Now, if we look at this next one, you're going to notice kind of the difference here. Right? With this information, we're not given enough. But just by adding this piece right here, we know consecutive angles are supplementary. Check, check. Opposite angles are congruent, and then right, this one also would have to be 60, so we have consecutive angles congruent. So is this a parallelogram? Yes, it is. So now we have two problems to work through and then get to the homework. So for this one, it says, for what values of x and y must PQRS be a parallelogram? So you have to figure out what's going to make this true. So we're going to start with is these sides across from each other. Right, to be a parallelogram, opposite sides are congruent. So I'm going to set 2x plus 1 equal to 3x minus 5. Right, if we do this, I'm going to subtract 2x over here. I'm going to add 5 over there. Sorry, it's kind of hard to see in there. 5 plus 1 is 6, which is equal to x. So we have now found what x is. We've already done some of the problem. Not hard to see. So x is equal to 6. Now what we can do is we can plug that in for this one right here. So this is really 6 plus 2, which would make this 8. And now we know also that both pairs of opposite sides would have to be congruent. And so that means that y has to be equal to this side right here, which is 8. So those are our answers for that one. If you need to pause that, feel free to do that as I move on to the next one. So last one here, right, we have these angles. We're trying to figure out how can we get an answer here. So you're going to want to start with, right, either start with your y's or start with your x's. But we want to solve for one of those variables first. I'm just going to start with the y's. So over here, I'm going to take that y plus 10 plus 3y minus 2 has to equal 180. Well, if we combine like terms, right, we get 4y plus 8 equals 180. 4y equals 172. For then the answer of y is equal to 43. So we found that answer right there. Now what I'm going to do here is we can actually, let's just solve for x as well so you can see both ways. So we're actually going to solve for x the same way we just did for y. So I'm going to set 12x plus 7 plus 4x plus 13 is equal to 180. I'm going to combine my like terms, so I get 16x plus 20 equals 180. I now get 16x is equal to 160, and I get x is equal to 10. So I showed finding y and finding x both ways using the fact that consecutive angles, right, these consecutive angles right here, these consecutive angles right there, that those are supplementary to one another. So that is it for today's lesson on proving quadrilaterals are parallelograms.